Okay, what we're going to look at now is how we would find the area of a triangle using the vector product, and then, as an extension, the area of a parallelogram. So, first thing we're going to remember is, from our GCSE and our normal maths, how to find the area of a triangle when you have an included angle. So you've got your classic triangle, and you can say from this that your area of your triangle is a half AB sine C. And you've used that for a long time. Now, we've met this new version of the vector product on additional pure. It's obviously when we've used it to find a unit vector, it's been really painful, but we can also use this to find the area of a triangle. We know, and you're told this in your formula booklet, that the cross product of A and B is the modulus of A times the modulus of B times the sine of the angle between them multiplied by the unit vector. And what we're going to do is we're going to think how we can link this to finding the area of a triangle as a value. Now we know that the size of your unit vector is going to be 1. So we know that if we're looking at sizes, then our cross product can be thought of like this, because your unit vector perpendicular to your vectors A and B has a magnitude or a size of 1. So keep that in your mind. We're now going to go back to our triangle. So think about our triangle, and this time I'm just going to have point A here. So I've got A, B and C, and I know I've got lowercase c, lowercase a, lowercase b. And I know from here that my area would be a half BC sine A. So I'm using my included angle through my sides B and C. What I'm now going to do is I'm going to change the labelling. I'm going to think of these lengths as vector lengths, and I know that I have to be careful of how I think of my direction. So I'm going to be using vector A to B, and I'm going to be using vector A to C, and I'm going to be looking at that angle there. Now, using the same idea, I know that the area of this triangle is going to be a half length, which of course is the modulus of vector AB, times this length, which of course is the modulus, and modulus of vectors are just values, numerical values, so we're multiplying, we're not using a vector product here. So that would be times the magnitude of vector A to C, so that's my half BC, so remember we did have that as B, and we did have that as C, times the sine of angle A. Now, let's compare that with what we wrote down a moment ago about our vector product. We know that our vector product of A times B is going to be the modulus of A, the modulus of B, sine theta. We know that that's exactly the same as what we've got there. That's exactly the same as what we've got there with our two vectors. So what we can do is we can think of the area of our triangle as a half times the cross product of these two vectors, AB times AC. And that is the formula for how you find the area of a triangle. If you want to find the area of a parallelogram, you just remove the half. So, an example. Okay, so there's your little bit of summary of it. Okay, let's do an example. The coordinates of 3 points are A, 2, 4, -1, B, 3, 0, 1, and C, -1, 5, 3. Find the area of the triangle ABC. So first of all, I know that the area of that triangle is going to be a half times the cross product of these two vectors. Now, of course, I could use B as my anchor, so it would be a half of BA times BC. I've used A as my anchor here. The first thing I'm going to do is find my vectors. So my vector A to B, obviously B minus A, is going to be 1, -4, 2. And my vector A to C is going to be -3, 1, and 4. What I'm now going to do is find the cross product of those two vectors. I know you know exactly what you're doing when you find the cross product. You've got a variety of methods. I'm just going to put mine in the calculator. Of course, if they wanted to show detailed reasoning, you'd have to clearly show how you found your cross product. So I think it's -18, -10, and -11. So you might want to check that, putting that in your calculator. I'm now going to find the modulus of this. So the modulus of my cross product is going to be square root of 18 squared plus 10 squared plus 11 squared. So the modulus of my cross product is going to be the square root of 545. So the area of my triangle is going to be a half times the cross product. So that's how we find the area of a triangle. If the question had been worded differently and had asked us to find the area of a parallelogram, so what I could have done, if I changed the question and said the coordinates of 3 points on a parallelogram, and we didn't know the 4th point, so if we change that to a parallelogram, find the area of your parallelogram, all you would do exactly the same, but you would think that the parallelogram, because of your line of symmetry, is simply going to be double the area of the triangle, so you get rid of a half. So that's all I would do, and at the very end, the area of my parallelogram, my top quality parallelogram, is the square root of 545. So in summary, okay, there we have it.